Hi, welcome to J Talks. I'm Josna Cardoza, and today I'll be talking about how large language models are trained. I want you to know that I'll be keeping this on a high level as this is a short talk. Now imagine teaching a child to finish your sentences. If I say once upon a, they'll probably say time. That's basically what LLMs do, but at a large scale. So, how do LLMs do it? They follow a set of processing steps. Let's understand these steps one by one. First, collecting data. We need data to train our LLM models, and hence, collecting the data becomes step one. Billions of words from books, websites, code, and articles. This comes as a training data set. It doesn't come ready made. We have to make it clean, a well balanced, and a correct data set so that our LLMs learn from the valid data. Second, tokenization. If you remember from one of my earlier talks, we have been through tokenization process in LLMs. Text is broken into chunks called tokens, like words or pieces of words or even characters. We will have vocabulary to look into for the valid words. And the algorithms like byte pair encoding helps the model to make sense from the unknown words as well. The third step, training objective. As I said before, the LLM model's job is simple. Predict the next token given the previous one. Let's say, for example, if the previous words are peanut butter, the model learns sandwich is most likely the next word, making it peanut butter sandwich. The fourth step is architecture. One of the well-known architecture in LLMs is transforms. It's a breakthrough architecture from 2017 that allowed models to handle context at scale. This is where magic happens. Transformers allow the model to look at all words in context using something called attention. That's how it learns long range meaning. For instance, if you say bank, it could mean bank near river, which is something totally different from bank near money. Fifth is scaling up. To have a smarter model, we need to train the LLMs on large data sets, which means more layers and more parameters. As the data size increases, processing ability reduces. Training requires thousands of GPUs running for weeks or months that let us train models with billions of parameters. So scaling up is important to keep the processing faster. And sixth one is fine-tuning and safety. These are required to make LLMs match the human tone. Training data is still small compared to actual scenarios. After pre-training, models are adjusted with smaller datasets. Techniques like reinforcement learning from human feedback, or in short, RLHF, help make responses more useful, polite, and aligned with human values. The interesting fact is, even after all this, the model doesn't understand the language like humans do. It's predicting what should come next based on statistical patterns. But when scaled up, those predictions feel more like human. So to summarize, LLMs are trained by learning to predict the next word, powered by transformers, massive data, and huge compute power. That simple idea of predicting the next word, which is repeated billions of times, is what makes the generative AI creative and innovative that we see today. I hope you found today's talk useful. Please like, share, and subscribe. I'll see you soon in the next talk.